Okay, so we've been doing some work on iteration and solving equations by trial and error, and a bit of work on rearranging over the last few lessons, and we're going to kind of try and pull that all together and look at a GCSE exam question. So there shouldn't be anything that's particularly new if you followed what we've done the last few lessons, but it's just kind of putting it all together. Now to teach you this stuff, I'm just going to show you a question that's very much like an exam question, and I'll just explain a little bit more about it, more than just going through the question, just to explain why we're doing what we're doing. It's probably worth saying at this point that to give a full explanation of how iteration works would take a really long time and is beyond the scope of GCSE, really, beyond the scope of what you need to know, and it would take a long time, and I don't think you'd get anything out of it. So I won't explain everything. So if you've got questions at the end of this, then some of those questions might be questions that you don't need to answer, but I'll do my best to explain where those places are as we come to it. Right, okay, so let's go through this. So the first part, show that the equation x squared minus 5x plus 2 equals 0 has a root between x equals 4 and x equals 5. Now we should just explain a little bit about this word root. Essentially it just means has a solution between. Now this is very similar to the sort of questions you did when you tried to solve questions by trial and error. And actually I might go a little bit further than the question at this point and perhaps just try and solve it by trial and error. So part A, now what it's saying is that the answer, the solution to this, or one of the solutions, because this equation actually has two solutions, but one of them is between 4 and 5. Now we can tell that because if we substitute x equals 4 into this equation, we get 4 squared minus 5 times 4 plus 2. Now 4 squared minus 5 times 4, that's 16 minus 20 plus 2. That's 16 minus 20 is minus 4 plus 2 equals minus 2. Now that answer, if I compare it, because what I want to find is the value of x such that x squared minus 5x plus 2 equals 0. So this answer is a little bit too small because it's less than 0 and I wanted it to be equal to 0. If I try x equals 5, so if we do 5 substituting into here again, 5 squared minus 5 times 5 plus 2, that's 25, minus 5 times 5 is 25 again, plus 2, that's positive 2. Now that's too big because we wanted it to equal to 0. So if this was just a question of solving by trial and error, at this point you might say, well, let's try and get a proper solution. So you might say, right, let's try x equals 4.6. I'm going to need a calculator at this, or 4.5. Let's go halfway between the two. So x equals 4.5. No, we don't. Just I should say at this point that we don't need to do this for this question. It's enough of what we've done here to say this is too small because it's less than 0. This is too big because it's bigger than 0, and so therefore the real solution, the real value of x, the root, to use the language in the question, is somewhere between 4 and 5. So what I'm about to do is kind of unnecessary for answering the question, but I just want to remind you of solving by trial and error. So I could try 4.5. So I could say, right, 4.5 squared minus 5 times 4.5 plus 2. And I could work that out. I might use my calculator. So 4.5 squared minus 5 times 4.5 plus 2 turns out to be negative 0.25. And again, that was, or that is, too small. So I'm kind of thinking perhaps it's a bigger value. So I could try x equals 4.6. It's only a little bit too small, so I'm kind of hopeful that 4.6 will take me a bit closer to 0, rather than jumping right up to 4.7. So let's work it out. 4.6 squared minus 5 times 4.6 plus 2. 4.6 squared minus 5 times 4.6 plus 2 gives me, oh, something's gone wrong. It's a plus rather than a minus, sorry. 4.6 squared minus 5 times 4.6 plus 2 gives me, okay, 0.16. So that was too big. Okay, so I'm thinking, right, okay, I have to keep going. This is too small. This is too big, so it must be somewhere between 4.5 and 4.6. So then I might say, okay, let's try x equals 4.55. Now I'm not going to carry on because this isn't really the purpose of this question, and I'd go through and I could get it more and more accurate and pin it down more and more in a way that you have done previously. But just to reiterate, all I need to do for now is to show that this was too small, this was too big. This is kind of answering a different question really, but just a reminder. Okay, now what iteration allows us to do is to be able to get an answer more quickly than going through all this process of gradually whittling it down. It gets you an answer much quicker, and I'll show you that when we come on to part C. But in order to get to part C, we have to do this first of all. So part B, show that the equation x squared minus 5x plus 2 equals 0 can be rearranged to give this. So this is what we did a little bit of yesterday. X squared minus 5x plus 2 equals 0, and we want to get it to that format. Now I'm noticing that that's got a square root in there, so I'm thinking I'm needing to rearrange for this one. Okay, so I'm going to rearrange to get this x on its own. I'm going to get the x squared on its own first of all. So I'll do this stage by stage. Let's take away 2 from both sides. So I've got x squared minus 5x equals negative 2, and then I'm going to add 5x to both sides. So we've got x squared equals minus 2 plus 5x, and then let's take the square root to get the x on its own. So we've got x is equal to the square root of this. Now I'm just going to change the order around so it matches that. So rather than write minus 2 plus 5x, I'm going to write 5x minus 2. So we've shown how we can rearrange this equation that we were trying to solve into this format. Now this is the bit that's, well actually before I say that, just to say, if you struggle to do the rearrangement in these exam questions, then usually that is only 1 or 2 marks. So if you can't do that question, that doesn't mean that you can't do the last part of the question. So usually they give you that, and then you'll notice that you're kind of using the answer here in this kind of iteration formula, which we'll talk about in a moment, kind of matches this one. So don't worry too much if you struggle to do the rearrangement. Some of them can be quite tricky. Do your best. You might pick 1 mark out of 2 if it's a harder one. This was a relatively straightforward one. Right, then we're going to use that here. Now this is the bit that is not fully explained, but basically this iteration formula, you'll have to cast your minds back a few lessons to when we talked about iteration, will help you work out the solution to this, the root of it, as we talked about here, much quicker than if you'd gone through this process. Now, why that works in the way it does is the bit that I'm not going to explain because it would take a long time, and I don't think it would benefit you. If you're really interested, let me know. I can probably point you in the direction of something which will explain it to you, but it comes with a warning because it is really hard to understand. So use the iteration formula xn plus 1 equals 5xn minus 2. So this is a formula that basically helps you to generate a sequence, if you remember that. So you put in a starting value, and here they say x0 equals 5, and you use this formula to generate the next term in the sequence. Okay, and then we use the one we got from there to generate the next term, etc. Now what I'll do, first of all, I'll go through this just kind of by hand, writing down all the working, and then I'll show you how you can use your calculators to be able to do that much more quickly. Okay, so let's do part C. Hopefully I've got room to squeeze it on the bottom here. So right, we've been told x0 equals 5. So if you like, that's the 0th term in this little sequence that we're going to get. X0 equals 5. And then we're going to substitute in. So to find x1, we substitute in 5 into this formula here, into this part of it. Okay, so x1 equals the square root of 5 times 5, which was this term, take away 2. So let's work that out. 5 times 5 is 25, take away 2 is 23, so we're finding the square root of 23. So square root of 23 turns out to be 4.79583 1523. Okay, I'm going to write down all the digits there. Okay, x2, then to work out the next one, we're going to use that figure in this formula again to work out x2. So perhaps I should have said this earlier. This formula is saying to work out the next term, xn plus 1, you do 5 times the previous term, take away 2, and then you take the square root. That's kind of what that stuff means. If you go back a few lessons just before half term, there was a bit of an explanation about xn plus 1 and xn. Okay, but if you want to, you can just kind of follow this as a process. So we're going to use this figure and substitute it in here. And I'm going to write down all the figures on this, but I will show you a quicker way in a moment. So x2 is equal to 5 times, substituting into here, 5 times, my previous term was 4.79581323, and then I'm going to take away 2 from that, and then we'll get an answer. So I'm going to do the square root of 5 times 4.79581523, take away 2, and that gives me 4.52538136. Okay. So now I can work out x3. Now you'll notice that these are not very different, and if we keep going, you'll find they get closer and closer and closer together. So next we'll do 5 times 4.5253811326 minus 2. Now at this point I'm going to show you the kind of quicker way of doing it, because I'm getting a bit sick of writing out all these numbers, to be honest. To be honest, in the exam it's unlikely that you'll have to do many of these. It's very rare that you'd have to do more than 3. And you can understand why, because it takes a bit of time. So the quick way of doing this is to do, remember that is my previous answer, so I can use this ANS button which will insert that answer into my next calculation. So I can do the square root of 5 times, but rather than typing the number, I'm just going to press that button, minus 2 equals, and I've got this figure 4.54168544. Now the nice thing is then is I can just, if I just press equals again, it will do this calculation again, but sticking that 4.54168544 back into the equation. So it will just generate, without me having to kind of do all this work, it will do 5 so my ANS is now 4.54168544. It will do that just at the press of a button. So I've now got 4.550651294. Again, I'm not going to write all the working out this time. x5 would be equal to, you can see they're not really changing very much now. I've got 4.555574219. Press it again. I've got 4.58275013. I'm just going to press equals a bunch of times just so you can see that this sequence is kind of homing in on a particular number, and it's doing it quite quickly actually. So I press it equals a bunch of times. 4.56. And you can see what have I got now? 4.5615. And if I press equals again, the first few digits of that aren't changing at all. So it's getting more and more accurate, and it's doing it quite quickly. So this is what I mean about it being a quick way to find a solution to this equation, because I knew from the work that I did back here that my answer was going to be somewhere between 4.5 and 4.6, but this is a quick way to do it. Now, in an exam, you don't have to do all of that. Often they'll just say to you, work out the first 3 terms in this sequence. Here they've worded it slightly differently. They've said, can you find the solution to 1 decimal point? Now what I'm looking for is the first time when these round to the same decimal place. So, you know, what it's kind of converging towards. So if I look at this, if I'm working to 1 decimal place, it's probably a good idea to look. It's a good idea to look to 2 decimal places. So if I just write these down, I've got 4.79, and then I've got 4.52, and then I've got 4.54 to 2 decimal places, then 4.55. Then this one is actually 4.56 to 2 decimal places, because that rounds up. Similarly, that's 4.56, and you can see, and when I pressed it loads and loads of times, it's kind of homing in on 4.56 something. Now what that means is that to 1 decimal place, my answer is going to be 4.6, because it's kind of to 1 decimal place, all of these figures, including this one, will round to 4.6. So to 1 decimal place, my answer is 4.6. Now I think actually that's probably a harder one than most of the ones that you'll come across in the exam. Right, okay. So that's an explanation of that question. I've printed out one more, and I'll go through this one much faster. If you want to, you could pause the video at this point and have a go at this one. Just put it in place. So here's the next one we'll have a go at, and I'll go through this one much faster, just as you would do for an exam question. Part C is possibly, we haven't really talked about it yet, so if you are going to have a go at it, just have a go at part A and B. Okay, right, let's go through this then. So first of all, this is a rearrangement style question, and we've got, I think it's one, looking at it, I think it's probably one of these harder type rearrangements. So if you were trying to and one of the reasons I know that is it doesn't have any, this is, let me just draw this in, it's a squared, and that's a cubed. Okay, it doesn't have a square root in it, it doesn't have a cube root in. So I know it's kind of, there's a bit of something funny going on. It was one of the harder type questions. Now you could try that first of all, and you might struggle to get that. So this is one where I'm going to kind of be a bit sneaky and work backwards. So if I start at the bottom here, x equals 3 plus 3 over x squared. Now I'm trying to get back to this thing. I'm going to multiply through by, it's going to be the easiest way to do it. No, actually, yeah, I'll multiply through by x squared, kind of going upwards. So if I multiply through by x squared, I've got x cubed that side. Don't forget that gets multiplied by x squared, and that's 3 there. And then you can see that this is kind of looking quite similar already, isn't it? So if I yeah, okay, all I need to do now actually is if I just take away x cubed from both sides, so I've got 0 equals 3x squared plus 3 minus x cubed. If I just change the order around, that's essentially the same as that, and that's all I need to do. So essentially it just involved dividing through by x squared, and that's perhaps a bit of a clue there, and then just shifting the order around a bit. So those are the same. That was quite I think that was quite a hard one. It's the sort of question that students sometimes struggle with. But as I said earlier, if you didn't get that, don't worry, you can pick up all the marks on here, and often in an exam situation there'd be 3 marks for a question like that. Okay, so now we're using this thing that we've worked out as part of the iteration formula, and they've told us x0 equals 3.2. So let's write that down first of all. x0 equals 3.2, and then for the purposes of exam questions, I would actually write down some of the working, even if you use the answer button on your calculator. So x1 equals 3 plus 3 over 3.2 squared. Okay, so x1 is 3 plus, put in a fraction, 3 over 3.2 squared, which gives me 3.292968. I'm going to write all these figures down. 3 point, let's put that down there, 29296875. Now that becomes the one that I put into the equation next. So x2 is equal to 3 plus 3 over 3.29296875 squared. But I'm not going to type that into my calculator. I'm just going to use the answer button. So 3 plus 3 over answer squared. That'll give me the next one. So I've now got 3.2766599786. And then x3, we're going to substitute that one in. So 3 plus 3 over this figure all squared, 3.2766599786 all squared. So I'm just going to press equals again because it's already got that answer in, so it will use that figure, which is again 3.279420685. So you can see it's kind of homing in on somewhere around 3.27. It's getting bigger, so it might go up to 3.28 possibly. But actually, for the purposes of this question, I don't need to know because it just asked me to work out x1, x2, and x3. So we're done. Now, part C is probably would be a 1-mark question in the exam. Explain what the values of x1, x2, and x3 represent. Now, they are actually solutions to this equation. So they're increasingly accurate solutions to the equation 3x squared minus x cubed plus 3. So, so they are increasingly accurate solutions to the equation 3x squared minus x cubed plus 3 equals 0. You might call them roots as well, you might see that written. Okay, well, have a go at the questions that I'll set on Show My Homework. Thanks.